In 1954, the Central Intelligence Agency overthrew the democratically elected government of Guatemala. This operation destabilized an entire nation for decades, but the reason was not communism, not nuclear weapons, and not some grand geopolitical chess move. It was a banana. Specifically, it was about protecting the profits of one company that had turned a simple yellow fruit into the engine of an empire. That was the United Fruit Company, and by the middle of the 20th century, it controlled more land, more railways, and more politicians in Central America than most actual governments did. The banana had become a weapon of economic control wielded by boardrooms in Boston against democracies in the tropics. That was 1954. By 2023, scientists confirmed that the exact same fruit sitting in your kitchen right now is facing a disease that could wipe it off the face of the earth within a generation. This is the history of the banana, and it is far stranger and far darker than you would ever expect from something you toss into a smoothie. Nobody was paying attention to the banana 10,000 years ago. It was not the fruit we recognize today. The original wild banana grew in the dense tropical forests of Southeast Asia, in the region we now call Papua New Guinea, and it looked nothing like the bright yellow crescent sitting on your counter. Wild bananas were small, stubby, and absolutely packed with rock-hard black seeds the size of peppercorns. You could barely eat one. The flesh was thin, bitter, and wrapped around so many seeds that biting into it felt more like chewing gravel than eating fruit. Some varieties were green, some were red, and some were barely larger than your thumb. If you had encountered a wild banana in the jungle 10,000 years ago, you would have walked right past it. You would not have guessed that this sad little fruit would one day topple governments. But early farmers in Papua New Guinea saw something in it. Through generations of selective cultivation, they figured out how to breed bananas that produced fewer and fewer seeds. They cross-pollinated mutant seedless varieties. They selected the plants that produced more flesh and less grit, and over centuries they created something extraordinary. A banana with no seeds at all, soft, sweet, and easy to eat. It was one of the earliest acts of agricultural engineering in human history, predating the cultivation of rice and rivaling the domestication of wheat. And it came with a consequence that would echo for 10,000 years, because a banana with no seeds cannot reproduce on its own. Every single banana plant from that point forward had to be grown from a cutting of another banana plant, a chunk of the root system called a corm, replanted in new soil. Every banana was a clone. Every plantation was a genetic copy of itself. And that detail, that tiny biological quirk that made the banana seedless and delicious, would eventually become the most dangerous weakness in the entire global food system. From Papua New Guinea, the banana spread along ancient migration and trade routes. Polynesian voyagers carried banana plants across the Pacific to new islands. Traders brought the fruit westward across Southeast Asia and into India, where it was documented in ancient Sanskrit texts and Buddhist literature as early as 600 BC. Arab merchants carried the banana along trade routes into the Middle East and the eastern coast of Africa. By the time Portuguese sailors encountered banana plantations in West Africa in the 1400s, the fruit had already been cultivated on 3 continents and adapted to dozens of local environments. The Portuguese and Spanish carried banana plants across the Atlantic to the Caribbean and Central America, where they discovered something remarkable. The volcanic soil and tropical climate of countries like Honduras, Costa Rica, and Colombia were almost supernaturally perfect for growing bananas. The plants exploded in those conditions. They grew fast, they produced massive bunches, and they thrived with minimal effort. Central America did not just grow bananas well, it grew them better than anywhere else on Earth. And this is where the story takes a turn nobody expected. Enter Minor Cooper Keith. In the 1870s, Keith was a young American entrepreneur who had been contracted to build a railroad through the brutal jungle interior of Costa Rica. The government in San Jose wanted a rail line connecting the capital to the Caribbean port of Limon to facilitate coffee exports. The project was a nightmare from the start. Workers died by the thousands from malaria, yellow fever, and snake bites in the sweltering Costa Rican rainforest. Of the 700 workers Keith initially recruited from New Orleans, nearly all of them died within the first year. He brought in laborers from Jamaica, China, Italy, and Honduras. They died too. Keith lost 3 of his own brothers to disease during the construction. The railroad was bleeding money faster than anyone could fund it, and Keith needed a way to pay for it. So he started planting banana trees along the rail lines. The idea was simple. Use the railroad to ship bananas from the interior to the coast, load them onto boats, and sell them in the United States. It was a side hustle to fund a railroad. It became something much bigger. By the 1890s, Keith's banana operation was generating more money than the railroad itself. Steamships packed with green bananas left the port of Le Mans every week bound for New Orleans and New York. The bananas arriving at American ports were unlike anything consumers had tasted before. The variety was called the Gros Michel, which translates from French as Big Mike. And it was by all accounts a spectacular fruit, bigger, creamier, and more intensely flavored than any banana you have ever eaten. It had a thick skin that resisted bruising during the long ocean voyage. It ripened evenly on store shelves, and it tasted almost like banana candy. If you have ever wondered why artificial banana flavoring tastes nothing like the banana you buy at the grocery store, this is why. That artificial flavor was based on the Gros Michel. The banana you eat today is a completely different fruit. In 1899, Miner Keith merged his banana operation with the Boston Fruit Company, a rival operation run by Andrew Preston. Together, they formed the United Fruit Company, and with that merger, one of the most quietly terrifying corporations in modern history was born. The United Fruit Company did not just sell bananas, it swallowed countries whole. Within 2 decades of its founding, it owned over 1 million acres of prime agricultural land across Guatemala, Honduras, Costa Rica, Colombia, Panama, and Ecuador. It controlled the railroads that connected plantations to ports. It controlled the telegraph lines that connected towns to cities. It controlled the port facilities where bananas were loaded onto its own fleet of refrigerated steamships, a fleet so large it was nicknamed the Great White Fleet. In some countries, it controlled the postal service. It built company towns where workers lived in company housing, bought food at company stores with inflated prices, and were paid in company script. Metal tokens that were worthless anywhere outside the plantation grounds. The company was not operating within these nations. It was operating as a parallel government alongside them. And in many cases, the men in the boardroom in Boston held more actual power than the elected officials in Central American capitals. The term Banana Republic did not come from nowhere. It was coined by the American writer O. Henry in 1904 to describe Honduras, a country so thoroughly dominated by the United Fruit Company and its competitors that its political system functioned as little more than a rubber stamp for corporate interests. And Honduras was not unique. Across Central America, United Fruit executives met regularly with local politicians, military leaders, and American diplomats to ensure that governments remained friendly to their operations. If a government raised taxes on banana exports, United Fruit pressured Washington to intervene. If a president tried to redistribute unused company land to poor farmers, United Fruit funded opposition movements and planted stories in the American press. If a country elected a leader who threatened the company's bottom line, United Fruit picked up the phone and called the CIA. This is the part that even the most cynical person would struggle to believe. In 1951, Jacobo Arbenz was elected president of Guatemala on a platform of land reform. Guatemala was one of the most unequal countries in the Western Hemisphere at the time, and the United Fruit Company was a major reason why. The company owned over 42% of Guatemala's arable land, and it was only actively farming a small fraction of it. The rest sat idle, held in reserve. Meanwhile, roughly 100,000 Guatemalan families had no land at all. Arbenz proposed a law called Decree 900 that would redistribute unused land to landless peasants. The law offered United Fruit compensation at the value the company itself had declared on its tax filings. United Fruit had been dramatically undervaluing its land on tax forms for years to reduce its tax burden. So, the compensation amount reflected the company's own dishonesty. The company was furious. United Fruit launched a public relations campaign in the United States, accusing Arbenz of being a communist agent of the Soviet Union. The campaign was led by Edward Bernays, the man widely considered the father of modern public relations and a nephew of Sigmund Freud. Bernays planted stories in major American newspapers, organized fake grassroots opposition groups, and convinced journalists and politicians that Guatemala was falling to Soviet influence. He arranged for American reporters to visit Guatemala on carefully staged press trips designed to make the country look like a communist stronghold. It was not true. Arbenz was a moderate social democrat, not a communist. His land reform was modeled partly on programs in the United States itself, but the campaign worked. In 1954, the CIA launched Operation PB Success and overthrew Arbenz in a military coup that installed Carlos Castillo Armas, a compliant military officer, as dictator. Guatemala descended into a civil war that lasted 36 years and killed an estimated 200,000 people. Think about that for a second. A fruit company helped overthrow a democracy, and Guatemala was not even the worst of it. In 1928, workers at a United Fruit banana plantation near the town of Cienega in northern Colombia went on strike. They were demanding basic rights, actual cash payment instead of company script, an 8-hour workday, access to sanitation facilities, and written employment contracts. The Colombian government, under intense pressure from United Fruit and the United States, sent the Colombian army to break the strike. On December 6, 1928, soldiers opened fire on the striking workers and their families, who had gathered in the central plaza of Cienega. The soldiers used machine guns. Estimates of the dead range from 47, according to the official government count released at the time, to nearly 2,000 according to union leaders and later historical research. The Colombian government initially claimed that no one had died and that the strike had been resolved peacefully. The American embassy in Bogotá sent cables to Washington confirming the massacre, but recommended that the United States take no public action. The event became known as the Banana Massacre and was later immortalized by Gabriel Garcia Marquez in his novel 100 Years of Solitude, where he depicted the army loading corpses onto train cars and dumping them into the sea. The massacre was barely reported in the American press at the time. United Fruit continued operating in Colombia for decades afterward, as if nothing had happened. This was the world the banana built. A fruit that cost a few cents at the grocery store in Des Moines or Philadelphia was propped up by military coups, labor massacres, and the systematic exploitation of entire populations across Central and South America. The yellow banana on the breakfast table in a suburban American kitchen was connected by a refrigerated steamship to a supply chain that ran through some of the most violent corporate behavior of the 20th century. But the banana empire had a vulnerability that no amount of political manipulation could fix, and the clock was already ticking. The Gros Michel was perfect in almost every way. It tasted better, it shipped better, and it grew reliably across the entire tropical belt of Central America and the Caribbean. There was just one problem. Every Gros Michel banana on Earth was genetically identical. Every single one was a clone of every other one. They all descended from the same parent stock, carried the same DNA, and shared the same strengths and the same weaknesses. And when you plant millions of acres of genetically identical organisms, you are not building a farm, you are building a target. In the early 1900s, a soil fungus called Fusarium oxysporum, known informally as Panama disease, appeared in banana plantations in the Panamanian lowlands. The fungus attacked the root system of the Gros Michel, infiltrated the plant's vascular tissue, and blocked the flow of water and nutrients from roots to leaves. Infected plants wilted from the inside out, their leaves yellowing and collapsing one by one until the plant died. The fungus spread through the soil and water supply, and once it infected a plantation, there was no cure. You could not spray it away with pesticides. You could not treat the soil with chemicals. The fungus produced microscopic spores that persisted in the ground for decades, waiting for the next banana plant to infect. The only option was to abandon the infected land entirely and move to fresh soil somewhere else. And because every Gros Michel was a genetic clone, every single plant was equally vulnerable. There was no natural resistance anywhere in the entire population. Not one plant out of millions had the genetic variation to fight back. Panama disease moved through Central America like a slow fire burning underground. Plantation after plantation fell. Companies abandoned entire regions of Honduras, Guatemala, and Costa Rica, slashing their way into untouched jungle to carve new farms out of virgin soil. But the fungus followed, carried on contaminated equipment, in the mud on workers' boots, and through the rivers and irrigation channels that connected plantation to plantation. By the 1950s, the Gros Michel was functionally extinct as a commercial crop. The fruit that had built a global industry, toppled governments, and dominated breakfast tables across America and Europe was gone, wiped out by a microscopic organism that exploited the very thing that made the banana so easy to grow in the first place, its genetic uniformity. The banana industry was desperate. They needed a replacement, and they needed one fast. Billions of dollars in infrastructure, shipping networks, port facilities, and political arrangements depended on the banana trade continuing. The company that had reshaped the politics of an entire hemisphere could not survive without a banana to sell. The answer came from an unlikely place. The Cavendish banana had been sitting in a greenhouse at Chatsworth House in Derbyshire, England, since the 1830s. It was named after William Cavendish, the sixth Duke of Devonshire, who had received the plant as a specimen from Mauritius and cultivated it as a curiosity in his private collection. The Cavendish was not as tasty as the Gros Michel. It was blander, its skin was thinner and more prone to bruising during transit, and it did not ship as gracefully across long ocean voyages. But it had one crucial advantage. It was resistant to Panama disease. The Fusarium fungus that had annihilated the Gros Michel could not infect the Cavendish. So the entire global banana industry pivoted. Every plantation, every shipping line, every grocery store supply chain switched from the Gros Michel to the Cavendish. New varieties were tested and discarded. Thousands of acres were replanted. By the 1960s, the transition was essentially complete. The Cavendish became the banana, the only banana. If you have ever eaten a banana from a grocery store anywhere in the world, from Tokyo to Toronto to Sao Paulo, you have eaten a Cavendish. And here is the detail that everyone missed at the time. They did the exact same thing again. Every Cavendish banana is a clone. Every single one is genetically identical to every other Cavendish on Earth. From the plantations of Ecuador to the farms of the Philippines, the industry that had just watched monoculture destroy the Gros Michel responded by creating another monoculture. A different banana, but the same fatal flaw baked into the foundation. It was not ignorance exactly. The companies knew the risk. They had lived through the death of the Gros Michel and watched billions of dollars evaporate as plantation after plantation fell to the fungus. But the Cavendish was the only commercially viable variety that could resist Panama disease while also surviving the brutal realities of industrial harvesting, weeks of refrigerated ocean shipping, and the bruising journey through supermarket distribution chains. There was no other option that met all the criteria, so they planted it everywhere and hoped that history would not repeat itself. For about 40 years, it looked like the gamble might pay off. The Cavendish thrived on a global scale that dwarfed even the Gros Michel era. Banana production grew exponentially. Over 100 billion bananas are consumed worldwide every single year. The banana became the most traded fruit on Earth and one of the cheapest items in any grocery store. In the United States alone, Americans eat more bananas than apples and oranges combined. The fruit shows up in cereal bowls and smoothies and lunchboxes and baby food. The Cavendish was not as good as the Gros Michel, but it was good enough. And the overwhelming majority of people alive today have never tasted anything else. To them, the Cavendish is what a banana is. The modern banana supply chain is a marvel of logistics and speed. A banana is harvested green on a plantation in Ecuador, or the Philippines or Costa Rica, washed in treatment tanks, sorted by size, packed into ventilated cardboard boxes, and loaded into refrigerated shipping containers. The entire journey from tropical plantation to supermarket shelf takes about 2 weeks. The bananas are kept at precisely 14 degrees C during transit to prevent them from ripening prematurely in the hold of the cargo ship. When they arrive at distribution centers in the destination country, they are placed in sealed ripening rooms where ethylene gas is pumped in to trigger the ripening process in a controlled, uniform way. The yellow banana you pick up at the store was green 5 days ago and hanging on a tree in another hemisphere 2 weeks before that. It is one of the most precisely managed supply chains in the global food system. But underneath all that precision, the same old vulnerability was waiting, and it did not wait forever. In 1990, a new strain of Fusarium oxysporum was identified in banana plantations in Taiwan. Researchers named it Tropical Race 4, or TR4. And unlike the original strain of Panama disease that killed the Gros Michel, TR4 can kill the Cavendish. The one thing the Cavendish was supposed to be safe from, the entire reason it replaced the Gros Michel, no longer applied. TR4 is a death sentence for Cavendish plantations. It works the same way the original Panama disease did. It enters through the roots, spreads through the vascular system, and chokes the plant from the inside. Infected plants wilt, turn yellow, and collapse. The fungus persists in the soil for 30 years or more. There is no chemical treatment that kills it. There is no fungicide that stops it. And because every Cavendish on Earth is a genetic clone, every single banana plant on every single plantation in every country is equally vulnerable. If you are wondering how that is even possible, so is everyone else. From Taiwan, TR4 spread relentlessly. It moved through Indonesia, Malaysia, and the Philippines throughout the 1990s and 2000s. It jumped continents to Mozambique, Jordan, and Pakistan. In 2013, it was confirmed in the Middle East and parts of sub-Saharan Africa. In 2019, it was detected in Colombia, the very heart of the Latin American banana export industry. That detection sent shock waves through the global market. The Colombian government declared a national emergency. Entire plantations were quarantined and destroyed. Workers were required to disinfect their boots, clothing, and equipment before moving between fields. Biosecurity protocols were implemented at ports and border crossings. But the fungus spreads through contaminated soil, water, and even the mud on a single pair of shoes carried from one farm to another. A single misstep by a single worker can introduce the disease to a previously clean plantation. Containment at that scale is nearly impossible. By the mid-2020s, TR4 had been confirmed in Peru, Venezuela, and other Latin American countries. And the question was no longer whether it would reach the major banana-growing regions that supply the world. It was how fast. And no, I am not making that up. The banana you are eating right now might not exist in 20 years. The global banana industry is worth roughly $25 billion a year. Hundreds of millions of people in developing countries depend on banana farming for their livelihood. In countries like Uganda, Rwanda, and Burundi, bananas are not a snack or a dessert. They are a staple food that provides a significant portion of daily calories for millions of families. Entire regional economies in East Africa and Southeast Asia are built around banana cultivation. The potential collapse of the Cavendish is not just an agricultural inconvenience for Western supermarkets, it is a humanitarian crisis in slow motion. Scientists are working on solutions, but none of them are easy and none of them are fast. Some researchers are trying to breed new banana varieties that resist TR4 while still tasting good enough and shipping well enough for the global market. That is extraordinarily difficult because commercial bananas are sterile. They do not produce seeds. Conventional breeding requires painstaking cross-pollination with wild banana species from the forests of Southeast Asia, and the results are unpredictable, slow, and often commercially unviable. A new variety might resist the fungus but bruise too easily for shipping, or ship well, but taste terrible, or taste fine, but produce too few bananas per plant to be economically worthwhile. Other researchers are working on genetically modified bananas that have been engineered with resistance genes from wild banana relatives. A team at Queensland University of Technology in Brisbane, Australia, has developed a Cavendish variety modified with a gene from a wild banana species that shows strong resistance to TR4 in field trials. Early results from test plantations in the Northern Territory of Australia are promising, but genetically modified crops face significant regulatory hurdles and deep public resistance in many countries. Getting a GM banana approved for commercial sale and accepted by consumers and governments across dozens of countries could take years, even decades. And the fungus is not waiting for the paperwork to go through. There is also the deeper question that hangs over the entire situation. Even if scientists develop a resistant banana, will the industry simply repeat the same mistake a third time? Will they plant the new variety as a monoculture across millions of acres, creating the same vulnerability all over again for some future pathogen to exploit? The history of the banana suggests that they will because monoculture is cheap, efficient, and profitable in the short term. Genetic diversity is expensive and complicated. It means growing multiple varieties, managing different harvest schedules, dealing with inconsistent sizes and flavors, and accepting lower yields. The banana industry has always chosen scale over resilience, efficiency over safety, and every time biology has eventually called the bluff. Some wild banana varieties in Southeast Asia and parts of Africa show natural resistance to TR4, but they taste completely different from what consumers expect. They are smaller, seedier, starchier, and sometimes barely recognizable as bananas to someone raised on the uniform yellow Cavendish. Convincing the global market to accept a fundamentally new kind of banana would require a massive shift in consumer expectations, marketing, and supply chain infrastructure. It has happened before when the world switched from the Gros Michel to the Cavendish in the 1950s and 60s, but that transition took decades, cost billions of dollars, and was driven by desperation after the Gros Michel was already gone. It was not a proactive choice, it was a panicked reaction. Meanwhile, small farmers in the Philippines, Indonesia, and East Africa are already watching their Cavendish plantations die. These are not multinational corporations with diversified portfolios and the resources to absorb losses and pivot to new varieties. These are families whose entire income depends on a single crop that is slowly being consumed from the roots up by a fungus they cannot see, cannot treat, and cannot stop. For them, the banana crisis is not a future hypothetical to debate at agricultural conferences. It is happening right now, in real time, field by field, plant by plant. The banana has been through all of this before, a beloved variety destroyed by its own genetic weakness, an industry scrambling for a replacement, the same structural flaw repeated because the economics demand it. The Gros Michel fell, the Cavendish rose, and now the Cavendish may fall too. The cycle keeps turning because the fundamental problem has never been solved. The world wants a cheap, uniform, predictable banana available year-round in every grocery store on the planet. And the only way to produce that at industrial scale is monoculture. And monoculture, as the banana has now proven twice, is a time bomb buried in the soil. The banana sits at the intersection of biology, economics, and politics in a way that no other fruit on earth can match. It funded coups and built corporate empires. It wiped out indigenous land rights and sparked labor massacres on tropical plantations from Colombia to Honduras. It went extinct once already, and the replacement is now staring down the barrel of the same fate. It is the cheapest fruit in the supermarket, and it carries one of the most expensive histories of any food in the world. Today, somewhere in a research greenhouse in Brisbane, a scientist is examining a genetically modified banana seedling under fluorescent lights, hoping it will resist a fungus that has been spreading across continents for over 30 years. Somewhere in the Colombian countryside, a farmer is inspecting yellowing leaves on a Cavendish plant, knowing exactly what that discoloration means. And somewhere in your kitchen, a banana is sitting on the counter, ordinary and unremarkable, as if none of this were happening at all. The banana is the most eaten fruit on the planet, and it might be living on borrowed time. What replaces it, if anything does, will depend on whether the world has finally learned from 10,000 years of making the same mistake, or whether we just plant the next clone and wait for the next fungus to find it. If this story changed the way you look at the simple fruit in your kitchen, please subscribe and like the video. We are digging up the hidden histories that have been buried for far too long. Help us cultivate a better understanding of our world. The next historical treasure will be uncovered soon. Don't miss it.